So we are finally at the point where we are going to use logarithms to solve problems. And so these are applications. We're going to use logarithms to go backwards. We're actually going to find time now. And so, for example here, a certain bacteria grows 40% every 5 hours. If the bacteria starts with 50 cells, when will it reach 150 cells? The first thing we should do is we should write our function. Our starting is 50. Our rate here is 40%, so that would be 1.4. And it grows that much every 5 hours, so this is going to be x over 5. Now the question is, when will it reach 150? So we're not going to put 150 in for x, which is time. We're going to put 150 on this side. And now we're going to try to solve to get x alone. So the first thing we're going to do is we're going to divide by 50. So this would be 3 equals 1.4 x over 5. Now at this point we would normally get stuck. But what we can do now is we can actually log both sides, kind of like if you square rooted both sides. So let me write it here. The log of 3 equals the log of 1.4 to the x over 5 power. And then we get to use one of our log rules, because this exponent can be thrown to the front. So this will be log of 3 equals x over 5 is out front times the log of 1.4. And now we want to get x alone. So we're going to divide both sides by log of 1.4 first. That would leave x over 5. And over here we have this stuff. Now to get x alone here, we're going to times it by 5 both sides. So x is 5 log of 3 all over log of 1.4. Now, here's where you get to go to your calculator. So in your calculator, 5 times the log of 3 divided by the log of 1.4. And I'm getting 16.3. So we could say after about 16.3 hours, we know that the bacteria is going to reach 150. Now the nice thing about these are we can always check our answer. We could do 50 times 1.4 and put 16.3 all over 5. I'm going to do that real quick here. And the answer I get is 149.74 blah blah blah. A bunch of decimals. Now as far as we're concerned, that is close enough. Okay, so another example here is half-life. This is actually how people do radiocarbon dating. So what they do is they look at the amount of carbon-14 that a fossil has, and then they know that a fossil always has started off with 100% of carbon-14. And over time, this carbon-14 is unstable and it disappears. It starts to decay. The atoms start to break down. And so if you measure it and you only find 83% of what should have been there, you can figure out how long this fossil or this pottery has been around. And so the first part of these is to decipher what this means. So that means every 5,700 years, we know that half is going to be left over. And so, to set up our function here, let's write 100% times 1/2, because it's halving. You could also write 0.5. Actually, to make life a little easier, why don't we just write 0.5? Then x all over 5,700. This means it starts at 100%. It gets halved every 5,700 years. And we want to know when that would equal 83. So there's the setup. I'm going to divide by 100 on both sides, and we will get 0.83 equals 0.5 x over 5,700. And if you remember the last time, we're going to log both sides. So I'll just write this, and I'll write log, and I'll write this, and I'll write log. And the reason we log is so that this exponent can come to the front. So let's write this all up here. Log of 0.83 equals x over 5,700 . Alright, I'm going to do two things now. I'm going to divide by log of 0.5. I'm going to times by 5,700. X is going to be alright. And that's the point where we can plug everything in. And I'm getting 1,532. So about 1,500 years old. Okay. So you'll see a lot of those. The last one here, investments. I have 2,000 invested in an account with 3% interest. How many years will it take to double? Alright, so our model would be y equals 2,000. And if it's 3% interest, it's going to be 1.03 to the x. Alright. Now, if the account wants to be doubled, we know that in the end we want to have 4,000. Okay, so if we divide by 2,000 on both sides, we're going to get 2 equals 1.03x. And I will log both sides. Okay, and this x, the exponent, can be put out in the front. So this will be log of 2 equals. And I divide both sides, so I will have this to put in my calculator. Alright. I see 23.4. So nearly 23.5 years it will take to double. And again, the great thing is we can always check this. So 2,000 times 1.03, and let's just put 23.4 in. And I get 5,007, which is close enough.